The Azure ML version 1 SDK is going away. What does that mean for us? Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Microsoft has made a big announcement about version 1 of the Azure Machine Learning Software Development Kit, or SDK. Today is April 29th, 2025, by the way, just in case you're watching this from the future. I do want to talk about the announcement, but this isn't the right place to discuss such things. There we go. That's much better. Now, if you are a user of Azure Machine Learning, you may recently have received an email from Microsoft that indicates that you may have some work to do. Specifically, Microsoft will no longer support version 1 of the Azure Machine Learning Software Development Kit as of June 30th, 2026. That gives us a bit more than 1 year to move away from SDK v1 and switch over to version 2 of the SDK. The rest of this email gives a bit of explanation and the call to action, but I think we've got the idea here. Microsoft has also put together a migration guide for switching from SDK v1 to v2. It's a pretty informative guide, and I'll leave a link to it in the description below. What I'd like to do in this video is give you a few ideas of how you can know if this deprecation will affect your code, talk about some of the key blockers that might keep you from moving to the SDK v2, and walk through this upgrade guidance and share some of my own thoughts. Let's dive in and see what the hubbub is all about. This is the Azure ML Upgrade Guide. We are going to walk through this, and I'll add a bit of additional commentary along the way. Before we get too far, I think the first big question people will ask is, how do I even know that I'm using the SDK v1 or v2? Let me try to disambiguate that really quickly. First, are you using a language other than Python and interacting with Azure ML via an SDK rather than the AZ CLI or calling REST endpoints? If so, you're on SDK v1. Microsoft used to provide SDK support for R, but they deprecated that a few years back, leaving us with only having a direct Python SDK. If you happen to be using the Azure Machine Learning SDK for R, it's probably time to give up that ghost. You don't have to switch from R. You only need to use the Azure Command Line Interface, or AZCLI, to execute your R code against an Azure ML workspace. Okay, next test. I'm using Python. Which version of the SDK am I using? There's an easy way for me to tell. First, get into your favorite terminal, or at least the one you've got in front of you. If you use virtual environments for Python code, like I highly recommend you do, make sure you're in the right virtual environment, as I am here. Next, we are going to run a quick pip show command. I'll run pip show Azure ML core. This is the name of the SDK v1 in Python. As we can see, after a moment, I have no results, meaning that I don't have the SDK v1. Let's now look for the Azure AI ML package. After a moment, I see some results come back. This tells me that I have the SDK v2 installed on my machine, and that's a good sign. Also, in Python code, if you import from azure.ai.ml, you're in good shape, as that's the SDK v2. If you are importing anything from azureml.core, you will want to upgrade. Finally, as far as the Azure CLI goes, check your installed extensions using the command az extension list. This will show you the extensions that you have installed already. Running this command, we can see that I have a couple of extensions on this machine, including the ML extension. That's the one that you want to see. If you see ML, that is the CLI v2. By contrast, if you see Azure CLI ML, you've still got the v1 extension, and you will want to switch to v2. And as a quick note, that support is going away on September 30th of 2025, so you have even less time to switch Azure ML CLI versions. Okay, with that important question out of the way, you should have a better idea of the extent to which this change will affect you. Scrolling through the first bit of the upgrade guide, we can see prerequisites and the reasons why you might want to switch to v2. Other than the fact that Microsoft is eliminating v1, of course. They do throw in a nugget that new Azure ML features will be V2 only, and this has been the case for quite a while. After that, we see a table answering the question of which V2 API you should use. In most of the videos that I have on this channel that relate to Azure ML, I use the Python SDK. But you can do all of the same work using the Azure CLI. And I've even shown how, at the end of the day, both interfaces are sending the same commands to the Azure ML compute that performs training and inference. The advantage to AZ CLI is that you don't need to write all of your code in Python. Though, honestly, you probably will anyhow because it is the lingua franca of machine learning. After that, we see a table of mappings from the Python SDK v1 to v2. There's a lot in here, but I'll try to hit the highlights as we go through each of the following links. The first document is upgrading Workspaces to the SDK v2. We get some comparison code between the two versions. One big difference in v2 code is that most of our operations work off of an ML client class, and that includes workspace management. Instead of passing the resource group and the subscription directly to the workspace, we can connect to an ML client using those details, as well as our credentials, and can then access resources, including workspaces, through that client. But it is important to note that the workspaces you created with SDK v1 will still operate just fine. There's nothing you need to do to convert workspaces over to SDK v2. Realistically, the only part about workspace management that might be concerning is the link around network isolation. Scrolling down on that page to this section on network isolation changes with v2, we can see why there is a difference. In the SDK v1, as well as the original Azure ML API, we performed most of our operations at the workspace level. So the way to isolate resources was to enable a private endpoint on the workspace, and that would automatically protect most of your operations. But with v2, there are ARM operations that remain public. I did some work with a client where they absolutely could not have any public interactions over Azure ML, and this was a real pain. 0 out of 10, do not recommend. But anyhow, if you want to lock down Azure ML in this modern era, Microsoft does provide some good guidance here on the process. I'll include a link starting with the tutorial on creating a secure workspace with a virtual network, and you can work your way down from there. Moving on to Datastore management, this is another good example of where we shift to the ML client paradigm in SDK v2. As an important note, v2 does not support using SQL-like data sources as data stores, something that you could do in v1. I will say that the SDK v2 is very heavily file-centric. If most of your data processing comes straight out of databases and you write back into databases, my strong recommendation is to save yourself a world of pain by switching to files. For training data, extract the data from your database and write it to a file. For inference, either send in files via the batch endpoint or make REST API calls via the managed online endpoint and have some calling code write the results into your database. You'll tear out much less hair that way. In short, you can reuse any existing object storage data stores, such as Azure Blob Storage or Azure Data Lake Storage Gen 2, but your database data stores are going away. Also, I am a bit biased, but I kind of prefer the v1 datasets in Azure ML, especially for simpler tasks where I don't have proper ML tables set up. Fortunately, you can still use these, and it seems that Microsoft will continue to support them after the SDK v1 is gone and buried. Let's move on to compute instances and clusters. These changed a little bit, but functionally they are quite similar between SDK versions. I will note that if you're trying to use serverless compute, that is a v2 only feature. The first significant change we see here is in terminology for executing scripts. In SDK v1, we had separate ideas of experiments and runs, similar to what we see in Azure ML Studio. Instead of using an experiment class and submitting runs off of the experiment, we submit jobs. In this code example showing the differences, one thing I wish they would indicate is that in the create or update method, you can include the experiment name as a parameter. Here's another significant change: hyperparameter tuning. If you were used to the patterns for SDK v1, you'll find that things have changed pretty significantly for SDK v2. Let's take a peek. In SDK v1, we had the hyperdrive namespace and different forms of building our hyperparameter space for tuning. We would create a sampling policy, an early stopping policy, and a configuration for hyperdrive. Then we would submit this as an experiment and run it, gathering our results. By contrast, the SDK v2 code uses the sweep namespace. Instead of experiments, we have jobs, and our job command definition includes details on how we specify the hyperparameters rather than defining it in a separate section. Then, in our command, we have a sweep method to configure the sweep job. That sweep job lays out how we want to manage our hyperparameter sweep, and we can also specify limits for how many trials we'll run, as well as what our early stopping criteria are, if any. In short, that's a pretty big change. Similarly, parallel run steps have become parallel jobs. This is a more significant change as well, and if you were using these in the SDK v1, I recommend paying close attention to this section, as it is not a trivial translation. You'll have to deal with several structural changes, including experiments to jobs, a very different mechanism for pipeline execution, and differences in how you specify input and output datasets. Speaking of pipelines, the next section focuses on translating SDK v1 pipelines into SDK v2 jobs, as there is no longer the idea of a separate pipeline. Everything is a job, but jobs may have different types. Scrolling down to the SDK v1 code, we can see an example of a pipeline that we would have previously created. We load a workspace, create or load an experiment, create or provision some compute to execute our pipeline, load a dataset, create a destination for our pipeline outputs, and then create a series of Python script steps to run the pipeline steps in order. This sample shows a training step, a scoring step, and an evaluation step. Then we create a pipeline that is a list of each of these steps in the order that we want. The last step has us submit the pipeline as a run on an experiment. By contrast, the SDK v2 code is a bit different. Some of the high-level ideas are the same, but how we get there is quite a change. We start by loading up our ML client and then attaching a compute cluster. From there, I'll scroll down to the pipeline section with the @pipeline decorator. This is where we define each of the steps of our job. In here, we still see training, scoring, and evaluating, just as before, but they are function calls rather than Python script steps. We need to specify the output of the final step of our job, which will be the evaluation output and the model itself. Below the definition of our pipeline, we create a pipeline job, specifying the training data and test data that we want to use. In this case, they're using the same Titanic data set for both training and test, which isn't particularly great. But this is just a demonstration of code rather than proper ML practices, so I get it. But as someone trying to add a bit of value to the documentation in the form of this video, I will say that if you are following a pattern like this, make sure your scoring data is different from your training data. And if you want to know why, leave a comment below. Finally, we submit the job. As you can see, we get to the same location, but it is not a trivial mapping. Moving on to Azure ML's automated machine learning capability, much of this will be the same going from SDK v1 to v2. Yes, we are using different namespaces, and we replaced the AutoMLConfig class in v1 with a classification class in v2, but as you can see when comparing these two sets of code, the practical differences are a bit smaller than what we saw for pipelines. As far as model management goes, Microsoft has, thankfully, made sure that the deprecation of the SDK v1 will not ruin any models you currently have deployed. If you deployed an older model using the SDK v1, it will still be there and it will still work. You can even use the SDK v2 to run inference against that model. This article shows how the code changes for registering a model between SDK v1 and SDK v2 work. In v1, we called a register function. By contrast, with the SDK v2, we instantiate a model object. Then we pass that object to the create or update function on the ML client's model's property. Our next article of significance concerns endpoint deployment. In the olden days, we used the SDK v1 or CLI v1 to deploy models either to an Azure container instance or to the Azure Kubernetes service. You can still do this, but Microsoft offers managed endpoints and Kubernetes endpoints to simplify the task a bit, and they recommend switching over to that. You get some nice advantages in moving to this new style of endpoints, including the ability to deploy your models via a serverless API, which is great for models you rarely use. If you have a low latency requirement, you can use the online managed endpoint instead and get responses quickly without waiting for that serverless capacity to spool up if you haven't used it in a while. And for larger scale inference that may take a while and return large amounts of data, that's what a batch endpoint is for. Here's my personal take on the matter, noting that this is entirely my opinion and not something I've ever discussed with anybody who works for the Azure ML team. I think that they realized most people creating models in Azure ML don't have the containerization chops to deploy to a Kubernetes environment and take full advantage of those capabilities. Yeah, at larger companies, you can get enough division of labor to have someone specialize in Kubernetes and someone else specialize in model development. But for many firms, there isn't that skill set in place, and Kubernetes administration skills are pretty much orthogonal to data science and machine learning skills. That's why so many of us used Azure Container Instances, even though Microsoft did their best to dissuade us from them. I could realize that ACI wasn't a great choice for a steady production application, but I could get one out in a few clicks and didn't have to learn about virtual networking, as well as Kubernetes concepts like deployments, pods, services, and mappings. Thus, Microsoft put a lot of effort into making the current set of endpoints much more robust than Azure Container Instances, but without us needing to learn Kubernetes administration skills. In other words, if you're still deploying things out to Azure Container Instances, it's a good idea to make the switch. Scrolling down to the code section, we can see what it looked like to create an Azure ML endpoint on an Azure Container instance. We would first create an inference config, telling our endpoint where it could find the code for our model, as well as the scoring script. Then we define the resources we want in an Azure Container instance and deploy. Pretty easy, which is why so many of us used this. In SDK v2, things are somewhat similar. We retrieve the model and environment, and then create a code configuration that points to our code, as well as a scoring script. From there, we create a managed online endpoint. This is half of the battle, but if you've seen my videos on deploying models, you know that we need more than just an endpoint, which serves as a proxy that routes to where we'll host the code. We also need a deployment, which is the actual location or set of locations hosting our model. In this case, they create a managed online deployment specifying a single instance of a standard F2S v2 virtual machine. They then route 100% of traffic to that deployment. Below, we see a quick comparison of how to perform inference against an SDK v1 model running in ACI versus an SDK v2 model running on a managed online endpoint. Invocation has changed a bit. Notice that once again, we see the move to a file-oriented paradigm, as we need to send a request file rather than a JSON blob. Okay, that was a lot. We're back on the upgrade page, and it then moves into some summarized instructions and recommendations for each major category. I won't go through each of these again, as much of this is a repeat of what I've already talked about in greater depth. But I will scroll down to the designer section, as we didn't cover that. If you are a user of the Azure ML Designer, rest assured that the designer is still there for v2 usage. You can continue to use your v1 data assets as though nothing has changed. My recommendation is to get familiar with the v2 custom components. You can switch between the classic pipeline and the new custom components style using the tabs at the top of the designer page. I should warn you that if you're used to the v1 style pipelines that we've created on this channel, v2 pipelines will be a new learning experience. But they're not pushing us off of the classic pipeline components just yet, so at least it's still there for now. Scrolling down a bit more, we can see an important note about secrets management. The SDK v1 had capabilities around setting and getting secrets that are no longer available in SDK v2. Instead, use the Azure Key Vault Secrets Python package to work with those secrets. It's a bit of extra effort compared to one SDK having Key Vault and ML capabilities, but from an architectural perspective, this makes more sense. The documentation then provides some more explanation of why you should use the SDK v2. We'll breeze past that and get to the section on using v1 and v2 together. Basically, the Azure ML team has done a pretty good job of not breaking backwards compatibility between the various Azure ML assets. Yes, the API model has changed, and some things aren't quite the same as they were before. But for the most part, you're not doing a complete rewrite of everything. And because SDK v1 and v2 can operate in the same workspace, you don't have to modify all of your code in one big push. Do it over time, slowly rewriting components as necessary until you're fully on v2. Finally, I do want to call out this warning at the end that you should not use v1 and v2 code in the same Python script. You technically can, but it's easy to get confused given the similar naming of assets across each. I know we looked at a lot, and it might seem a bit daunting at first, but if you're currently in charge of a bunch of SDK v1 code, I recommend taking some time to sit down and read through this guide, preferably well before June of 2026. Hopefully this helps clarify what it means to switch from the Azure ML SDK v1 to v2. I won't pretend that this is a trivial activity or something that most organizations could knock out in a couple of hours, especially because many of the methods and mechanisms are different between these two versions. But there is plenty of time to plan and implement that migration, and the SDK v2 does have some nice quality of life improvements. Also, my corporate overlords, by which I mostly mean my wife, would be very upset with me if I didn't shill my own services. So if you're looking to migrate your Azure ML implementation from v1 to v2, schedule a call using the Catalyxy services link below and let's talk turkey. We'll have links and show notes in the description below. And until we see each other in the next video, take care.